So hi, I'm Nicolas Dolenc, for those who don't know me, representing my brand, a founder's friend today, and collaborating with Toughbyte and Oleg. Met Oleg this past winter when I was doing my blog called Just Thoughts, and was really inspired by Oleg's journey. I realized marketing in this event, we didn't highlight Oleg enough, maybe, and his expertise of you've learned coding by reading a book.
That's right.
So like with this intro, in your own words.
Pre-AI.
Yes, pre-AI.
Pre-home computer.
Yes. So pre-home computer, built the first online multiplayer game.
A mobile multiplayer game.
Mobile multiplayer game from back in the day. So we are trying to strip away all the hype. However, Oleg has built something for this day and age, his own AI agent platform, which is called Ghostlyn, and you'll get access to that. And then we'll discuss a bit about like the design principles of it, and then hear more from all of you, like how familiar you are with the workflows and the different tools, and then hopefully have a very vivid discussion towards the end of the session of the different sort of AI agents that are out to play and how Ghostlyn maybe differ from that. But without further ado, Oleg, please say a few words in your own words.
Sure.
And then we'll go and introduce all of you get a chance to introduce yourself as well.
Well, any chance you could click through to that page so that the clicker works? All right, cool. So just to sort of go through the agenda very concretely. So first of all, we're going to be here till a bit before 6. Hope that's okay for everyone. If somebody has to leave early, that's cool too. Just let us know in a bit in advance. So, each of these blocks is going to be about 30 minutes. So the first one, the idea is that we are going to introduce you to each other, and then we're going to form groups based on your role or sort of area of expertise. So don't get too comfortable in your current spot, and you may have to move. And then after that, there'll be like more of a theoretical session where I'll go through some slides on what an AI agent is, how we should go about building one, and so on and so forth. Then after that, there'll be like an exercise you can do in groups. And then after that, we'll have a session on scoping where we'll sort of talk about how to plan, how to build an agent rather than diving straight into it. Because I think with AI in general, doing stuff is easy, but if you don't plan it properly, it's a little bit like driving a Formula One car. You push the pedal to the metal and you end up crashing. So you need to be able to slow down on time so you can take those corners. And then finally, we'll actually try and build 1 or 2 simple AI agents, either individually or in groups. We can make this pretty interactive. The clicker isn't working for some reason. All right, there we go. Oh, hold on. Is that working now? Yeah, now it's working. Cool. So Nicolas has already introduced us.
We got a couple of QR codes.
Yeah. So if you want to connect on LinkedIn, you can scan those QR codes. But if you don't, we're going to look you up later and connect to ourselves. So, but yeah, very briefly, apart from the stuff that Nicolas mentioned, I've most recently started Toughbyte, which I'll say a few words about later. But kind of the reason we're doing this workshop is also because I've been working with Ghostlyn for the past few months. And Ghostlyn is an AI kind of a work assistant that you can use to build an agents, or rather it's super agent that lets you sort of create skills and complete various tasks. So part of the reason why we're doing this workshop, just so you know, like what our agenda is here, is that we're not trying to sell you anything, but what we do want is feedback on Ghostlyn. So the exercises we'll have here will involve like trying out Ghostlyn and trying to create like certain automations and agents within it. It's completely free, so you're welcome to use it.
And the other agenda is to try out the workshop and see what works, and then in order to make those more valuable in the future as well.
Yeah, very good. All right, but enough about us. Okay, actually maybe couple more words about us. I forgot we had these slides. So Toughbyte, well, we'll share the slides with you afterwards, but I've been running the company for about 10 years, and we've recently pivoted into being an AI consultancy. And what that means is we basically help companies make the most of AI. So the way it works is we usually run an audit in the beginning, and we figure out what are the gaps in AI adoption in the company, and then we make come up with a plan for what sort of pilots you should run, which things to automate with the help of AI, and so on. But we also do development, so we can build agents or build MVPs or introduce sort of AI coding assistants into development workflows. We also do recruitment, and that's actually historically what we focused on in the past. And finally, we are also starting to do workshops again. We did workshops ages ago, but it's been probably at least a couple of years since I ran the last one, so I'm a little rusty. So bear with me here. And then Ghostlyn, as I mentioned, it's an AI work assistant. Maybe worth mentioning what sets it apart, and we'll go into this a little bit later, is that it's sort of a inference provider or model agnostic, which means that you can switch between different models like OpenAI, Anthropic, or even some open weight ones. The other sort of selling point is that it's meant for use within a team rather than individually, although you can quite happily use it as an individual as well. So there's all sorts of collaborative features in place. And finally, we try to make it as simple to use as possible. So it's quite easy to sort of extend its capabilities by, for example, creating connectors to new services, which other agent platforms typically require having some sort of an MCP connector for.
We will get into the terminology for those who are new to these things, and I will try to challenge Oleg to, or what we usually get into is simplifying it, because I started out with not a very strong technical understanding of this when we got to know each other. So kind of sparring on that, and please have any questions going through. But without further ado, we would like to hear from all of you. Who are you? What company and what role are you representing? And what is your current AI experience? And then we try to facilitate and cater that towards your needs.
This is supposed to be interactive, and I know having been sort of in the thick of it, building these things for a while, I know that some things may seem obvious to me, which aren't necessarily obvious to everyone in the room. Great, so let's get going. I just came across this today, and I thought this was kind of a funny in that it's also true. I think from hearing what you've said as well, I think the reality really is that there's so much noise on LinkedIn and other social media about how AI agents, how everyone's building AI agents, how they're firing all their employees, and so on and so forth. But the reality is that the actual people generating value are very few and far in between, because even though it's easy to get a nice demo going or a little prototype, you very quickly sort of hit a wall in terms of complexity of the system, it not being reliable enough, or in terms of it not having access to the data or the tools that it needs to be able to do the work that you want it to do. So let's try and sort of steer the conversation towards this right side of this picture, and think more about what are the cool things we can build, but also more importantly, what are the valuable things we can build, and what is actually worth building. Because now that building is becoming easier, I think planning and thinking about what to build before starting building is becoming increasingly important. Good. So before we start talking about agents, I thought I would start with the basics without going into too much detail. Let's sort of recap what a large language model is, and not from a technical perspective, but more from a point of view of how it behaves and how it's relevant to us. One way I've explained large language models in the past, which seems to resonate, is I don't know, for those of you that still remember the old Nokia phones that had text prediction, as you type, you get the next character. And nowadays you get the next word on your Android or iPhone. One way to look at large language models is that it's a form of text predictor, except that rather than being trained on the vocabulary of all the English or Finnish words, it's trained on like a large chunk of information that's available on the internet. So that includes code, books. In fact, a lot of the training data has been sourced from some pretty dubious sources like pirate sites and so on. And, some of these big players that we'll know and love have been sued and paid out to people because of the fact that some of the content they use that they perhaps shouldn't have. But once you're at that scale with that large number of parameters and that much data, all of a sudden, certain emergent patterns sort of occur, and maybe like the sort of most impressive pattern is that these models seem to be able to reason, right? And whether they're actually reasoning or not is kind of besides the point, because if we feel that their output is good enough and can be considered reasoning by someone who is like a subject matter expert, then it's as good as if it was actually reasoning. So I think all the debates about whether AI is sentient and AGI and so on is kind of pointless, because, as long as it's good enough, then it doesn't really matter. But what is important to understand is that fundamentally, these systems are all about predicting the next line of text. So it does not have enough information to be able to make an accurate prediction. What it will do is it'll produce something that seems as plausible as it can be and seems true, but is actually not, i.e. these models hallucinate. And that's very important to be aware of and understand when are the cases when these models could hallucinate. It's also important to understand that they are not sort of the equivalent of a brain, even though under the hood, a large language model is a neural network, which is kind of loosely modeled after a brain. But a brain has all sorts of like loops and connections going back, but a large language model only works one way. And the weights in the large language model are static. So once the large LLM has been trained, the weights don't actually change. So what that means is that the large language model itself has no concept of memory. And it actually also, this is another analogy I've used sometimes, it also has no sort of kind of extensions to it in the real world. So it's kind of like a brain in a glass jar, right? So it has no ability to actually perform any actions. And that's kind of
what would you say is the out of these conventional knowledge, like what are people getting completely wrong in the basics? Like what most people believe is to be true about LLMs, but it's actually not, like a contradiction here.
I mean, there's plenty, but one is people make wrong assumptions about what an LLM should be able to answer out of the box without sort of grounding or having access to any external or up-to-date data versus what it just cannot answer. So that's probably the biggest fallacy. People assume that there's certain things that it can answer reliably, whereas it cannot. The other one, I think, is that is sort of like this idea of anthropomorphizing these systems and giving them character and saying things like, oh, I like Claude because, Claude is very professional and I treat him a certain way. And when I talk to ChatGPT, I talk to her differently, and I sometimes like tell one that I'll go and talk to the other and then stop talking to her if she doesn't answer my questions. That's kind of the, I've heard people say this, and the thing to realize is that like that role and the persona that the LLM can play can change very easily just through like one line in the system prompt. So there's no like inherent really kind of like character or personality to the LLM. Anyway, we'll share these slides with you, but if you feel like you're not quite up to speed and have a good understanding of how things work under the hood, I strongly recommend checking out these two resources. So the first one is a blog post, which came out only about a month after ChatGPT came out, from Stephen Wolfram, who created Wolfram Alpha and Mathematica as well, I believe. But he does a very good job explaining about how LLMs work under the hood, in like a fairly non-technical manner. And then the second one is a video from Andrej Karpathy, who's recently joined Anthropic, I believe, but before was doing AI at Tesla, and is like a big educator in the AI space. But It basically just is him talking for a couple of hours about how he uses LLMs. And a lot of the stuff that he covers is also covered in this talk, but he talks about it from a kind of a day-to-day use perspective, and he has more visuals and so on. So that's worth checking out as well. All right, moving on then. What is an AI agent? So as I mentioned earlier, LLM, large language models have these like gaps in their capabilities. And an agent, in a way, is like the level up from there, the thing that plugs the gaps that the model has. So there's kind of two ways to, well, first of all, much like cloud computing back in the day, one has to realize that the word agent is extremely overloaded. So people can mean complete different things when they talk about agents. I've even heard people mentioning like robots in the context of agent and so on. So we're going to have quite a narrow definition, but also like we're going to have a couple of different definition just to sort of like triangulate on what an agent really is. So at a high level, an agent is a system that's able to autonomously execute certain tasks in pursuit of a goal. That's quite an abstract definition. If you look at what parts make up an agent, then it is the model, which is the LLM we discussed earlier. Then it's a harness, which is basically everything around the model that makes it useful. Then it's the tools, and we'll talk about tools in more detail later, but basically tools are like functions or things that the sort of agent can do, like search the web or fetch a web page or something like that. And then finally, it's the context. So it's basically the text, the tokens that are fed into the prompt that somehow modify the behavior, the output, the persona of the LLM's output, of the agent's output. So those are like the components of an agent. But in actual fact, like the way in which those components interact is that the agent harness runs the model that it gives access to, which it gives access to tools in a loop, right? So the idea is that in typical programming, you sort of hard code the things that your program does. And here you're giving the LLM, through its sort of like token prediction, the ability to decide what to do. You give it tools and you say, here are these tools you have access to. You can search the web or you can run some code or whatever. This is the goal that you've been given. Now decide which of these tools you should call to solve this problem. And give it the ability to do that not only once, but you give the ability to do that in a cycle until the model has determined that it's actually completed that goal. So that's the so-called agentic loop, right? So the model is given this instruction by the user or some external system. It sees the tools, it knows the goal it's supposed to pursue, it calls the tool, it gets the output, and then everything is fed back into the model again. And then like there's really no state in the LLM itself. It's basically just the same stuff being said over and over and over again until at some point the model has called the tools, got the results, somehow inferred the end result, the end goal from those results, or that it's confirmed that it's reached that goal, and then it stops. And once it stops, it hands over control back to the user, and the user can say, okay, so this is like the end result that I was after. I told you to find out who, I don't know, Nicolas from a founder's friend is, and it called tools to search the web, fetch Nicolas's blog, maybe fetch some other sites, then it synthesized all those results into a single response, and it's presented that to me.
And this, and these loops, this is what either you can make in a smart way or in a dumb way, and this is what is burning a lot of tokens and is costing a lot of companies a lot currently, right? Or
yeah, I mean, yes.
Yeah.
But there's more to it, so which we'll go into that later. But yeah, I mean, being able to run that loop effectively, so not giving the agents access to too many tools or giving the relevant context is really what like building good agents boils down to. But we'll cover all that in more detail shortly. Maybe an important thing to note is like, why are agents like such a big thing all of a sudden? I mean, one argument is that there's a lot of investors' money riding on this, so there's a lot of hype. But I feel like unlike the previous sort of waves of hype we had, there's really something real and important happening here. And regardless of whether we're in a bubble and it's going to burst, there have been some like real advancements in this field. And I would argue that actually already today, the models are good enough to get a lot more done than is currently being done. And that's because the problem isn't with the models anymore, although the models are getting better as well. The problem is with the harness and everything that's outside of the model that we just covered previously. But specifically, like the things that models are good at now that they weren't good at, say, a year or 2 years ago, are that they've become a lot more reliable. So it used to be that you tell a model, here are the tools, here's the goal, and it would just randomly not call the tools half the time, which obviously compounds after like multiple iterations of the loop. Now these models are able to run these loops continuously for a long period of time, calling the right tools and so on. Models are also able to do thinking. So in addition to seeing the output that it presents you with, models can now generate tokens that are not ever actually shown to you, where it's sort of like reasoning with itself to try and come up with a better result. Also, the context have increased. So context used to be 100,000 or less tokens. A token, by the way, is just a fancy way to say 4 characters. And now like 1 million tokens is commonplace. So all of a sudden, an agent is able to sort of keep a lot more stuff in its working memory effectively, and hence be able to work autonomously for a long period of time. The token costs are falling, despite everything that you're hearing. The way in which these agents or models are connected to external services is being standardized through the model context protocol. And also like the number of modalities that these models support. So in other words, supporting not only text, but also supporting audio and images is become possible. And we'll share these slides with you. Let's not bother clicking through to the link, but there is, or are we going to bother clicking through to the link? But anyway, there is this kind of a benchmark that tracks how good these models are doing agentic tasks. And if you check it out for yourself, you'll see that actually the horizon, so like how long an agent can run autonomously for, is doubling every 4 months at the moment. But actually the rate at which it's doubling is increasing, because 6 months ago, it looked like the rate was every 7 months. And now we're down to 4. So we're at this weird inflection point where soon we'll have agents that are able to run autonomously, not for like 2 days, as is the case now, but for like a whole month in pursuit of some sort of a goal. All right, moving on. Let's then talk about the model. We kind of said the models are good enough. It's all about the harness and everything else, but it's important to realize what sets different models apart and like why you should care about the model in the first place. So different models have different capabilities, like the number of tokens that it has its context window or working memory. Some can think, others cannot. Speed is a very important factor, because like the more complex your workflow, the faster you want it to occur. So you want the number of tokens being generated to increase, the number of tokens per second. Cost, as the number of tokens increases, starts to matter a lot more, because if you're paying a lot per token, you want to you're not going to be able to run as big of a job. And then an important distinction is whether the model is open weight or proprietary. So the thing with proprietary models is that you're kind of like locked into that model and that provider, and they're able to increase the prices or switch the underlying model like under the hood without telling you. Whereas with open weight models, you have the flexibility of where it's hosted, where you run inference, and hence like the costs are almost certainly always going to be significantly lower. It's all worth adding though that like in general, when you're prototyping, you're better off using just the most capable, expensive model. But as you go into production and start using the model more, then you can optimize. That being said, these open weight models like DeepSeek 4 that came out about a month ago are actually as good as the proprietary models, such as Claude Sonnet 4.6, but they cost like 1/16th of the price. And for like non-coding tasks, for general knowledge work, they're just good enough, and there's really no need to go with the more expensive models, and they're also faster. Okay, moving on then. Let's talk about harnesses. So we have sort of two ways to go here. And it's great that some of you have already experimented with building your own agents. But an important distinction is, do you try and build your own agent harness? And it's actually surprisingly simple. And there's whole frameworks. You can vibe code your own agent essentially without really understanding or having to write any of the code. And if you want full control, that makes sense. You get the ability to connect it to any interface like Telegram, Slack, whatever. Some technical skills are required though. And there's quite a lot of different options to choose from. So most of these libraries for building agents are called SDKs, or software development kits. The low-level one, which Ghostlyn is using as well, by the way, is called Vercel AI. And that's more like a bunch of Lego bricks that you assemble into an agent. Whereas, for example, the Claude Agent SDK is like a ready-made framework toolkit where essentially everything is designed for you. And you can just follow ready-made instructions and change some configurations. The thing to realize, though, is that the higher up the layer of abstractions you go, the more limited you become. And for example, Claude Agent SDK in particular, while in theory supports multiple models, in practice is a closed source. So you can't look at what's happening inside it. And also makes it easy to integrate with Anthropic's models, but not models from other providers. If you use an existing harness, and obviously you can mix and match and use different harnesses for different use cases. But if you use an existing one, the thing to things to think about are which data will the agent need to access? Are you okay with having access to only data in the cloud, or do you need access to local files as well? So do you go with Claude AI or Claude Cowork, for example? Do you want the agent to be able to run code? Increasingly, you do, even if you're not a developer. And then as we go further down the list, this is more in the territory that Ghostlyn answers, but it's how do you actually share the thing you've built with others? How do you collaborate? Where is it going to run? Is it going to run just on your computer or Mac Mini, like OpenClaw, or is it going to be running in the cloud somewhere so you don't need to worry about the infrastructure? There's some examples there. Ghostlyn, I'm not going to go too much into this. You'll hopefully get to try it out soon, but is just one harness out of many, but opinionated in some sense. Moving on, what's a tool? So we kind of said agents have access to tools, but what is a tool? So a tool is nothing other than a function in sort of programming terminology, so that the model is able to act rather than just generate the text. The way in which it calls the function is it generates the text call function with such and such name, with such and such parameters. So it's nothing more fancy than that. But it's important to realize that what an agent can do is defined entirely through the tools it has access to. And what the model sees is the name, the description, so what does that function do and when should it be used, and the parameters it accepts, as well as the return value. So tool use is nothing other than function calling. And again, just to recap, the model decides which tool to call. But it's actually the harness that runs it. So it's not the model, it's not OpenAI, it's not DeepSeek, it's not Anthropic, it's the agent harness that runs it. So in the case of Ghostlyn, say, the model might be running on, an inference might be happening on, say, Anthropic servers, but the actual tool calls are being made on the Ghostlyn server. And if you're running Claude code, then the agent runs on your computer and the functions are being called on your computer and not somewhere in the cloud. So what are some tools? And I've included the built-in ones, but that I think are important and pretty much every agent has. So searching the web is becoming increasingly important. The reason is that models have a cutoff date, and also they hallucinate if you ask them about a very niche topic. If you give the model a tool to search the web and fetch the pages, then they're able to go off, do that search, and then they're able to ground their response in the sort of answer that they've managed to gather from the most up-to-date information that's out there. And then the second thing that they're able to do is that they're able to run commands or code. So the reason why there's been so much excitement about the capabilities is that actually the models already have an understanding of how to run commands on a computer, to list files, read through a file, edit a file, make requests, and so on. So essentially, there is no additional sort of prompting needed. You just give it the tools saying, hey, this gives you access to the command line of a computer, or like a virtual computer somewhere in the cloud. Go wild, like use it to achieve whatever goal you've set for it. So that's why like these agents are quite simple to create and do. And then you're able to then extend these built-in tools with like external tools through the model context protocol or some other means. But what that allows you to do is, for example, connect to services such as Gmail, use the browser, access documentation, and so on and so forth. So basically, the sky is the limit here. Context. So when we sort of talk about how the agentic loop runs, it's important to understand that essentially every single time like the LLM runs, it's being fed the entire previous conversation all over again. I think most people assume that somewhere there is some sort of state maintained, and yes, it is maintained, but it's not being maintained by OpenAI or Anthropic. It's being maintained by the sort of agent provider, and sometimes it's not even maintained anywhere at all. It's just part of the memory on your computer or in the browser, and it's being fed back over and over and over again every single time. So actually, what that means is you can switch models halfway through a run. So, for example, if you're doing some sort of a task and you realize, oh, this requires like a much more powerful model than I'm currently using, then actually the agent harness is able to like completely transparently switch to using a different model, and you continue the same conversation without like any issues. But there's a limit on to how much you can feed into the model. And right now that limit is around 1 million tokens or 4 million characters roughly, which seems like a lot, but in reality, it's not that much once you start like doing tool calls, because when you do a tool call and you fetch a page, a whole Wikipedia page might be like, tens of thousands, 100,000 characters. There's all sorts of tricks and things being used to sort of compress that and make that more compact. But the reality is, if you have a long chat session and if you have a lot of tool use, then you're going to hit that limit pretty quickly. Once you hit that limit, something called compaction occurs, which means that basically everything stops. It seems like everything is frozen. And then what the agent harness does is it goes and tries to summarize all the previous conversations, figure out what's important or not, and basically turns the entire previous chat history into like a short summary with just the most relevant information. That takes forever, like minutes, and usually it summarizes all the completely wrong things. So like you do not want to hit compaction, and you want to do everything possible to stay below that compaction sort of threshold. And what you can do to avoid that is basically start a new chat every time you start a new task, or a new set of related tasks. So because by having like that old context in the prompt and starting to work on something completely unrelated, you're actually like degrading the performance of the agent, right? Because like with a 1 million context window, the large language model remembers well what was said in the beginning and what was said at the end. It misses a lot of the stuff that's in the middle of the chat conversation. So if you started the conversation talking about one thing, and then toward the end you're talking about something completely different, asking for something completely different, then it's going to get confused. It's going to get mixed signals, and it's going to go look in the wrong places or make the wrong conclusions and call the wrong tools or whatever. So important to pull in only the relevant information and restart the chat periodically. And something you can also do is you can use sub-agents. If you're using Claude Code, for example, you can just literally use sub-agents to do this work. You can even use sub-agents to do this work in parallel to make sure that the agent you're running spawns other agents that have like an empty context that do the work. Once they've done the work, they summarize their results and they feed that back into the main agent loop, which is then able to continue doing the work without having its context window polluted with like irrelevant details. Yeah.
Question on that. I read some empirical guidance that you should use the context window until it reaches 60 to 70% maximum, because until then it's the most productive, and the moment it starts to reach even above that, it starts to be poisoned.
Yeah.
It's something that you heard.
I don't think there's like a one correct answer because it depends on the agent harness, depends on the model, and depends on so many things. So I wouldn't like look at the 60, 70% number. Right. I mean, the rather than thinking like how much of my context window am I using and keeping track of that, what's much better to do is to just kind of periodically, like proactively offload context into a file or some sort of storage at a point in time when you feel like you have like completed a step in the task that you're trying to do. So for example, if you're trying to do a large task that's not running autonomously, where you constant input from you is needed to guide the agent, then every now and then it's good to write, hey, like document this in a markdown file, everything that's important that we've discussed so far. You know, and maybe like emphasize these and these points, or like the most recent decisions we made. And then what that means is that you have like a summary with the key facts and details and decisions that you made in a durable format. So if the agent hits compaction limits or whatever else happens, like you drop your computer in the bathtub or whatever, assuming you've obviously like somehow backed up that file using version control, you can come back and resume work from that point onwards by just telling the agent, hey, read this file and let's continue working on this from that point onwards.
So then the follow-up of that is to keep the context window under control. I mean, what are the techniques that is in the Kiro tool, but it's common everywhere, but use a spec-driven development that it does design tasks, or let's say requirement design tasks. This is one way, but is there any other better way? Because tasks is a bit awkward because
I mean, spec-driven development is essentially like the developer's way of doing what I just described, which is if you want to implement a feature, you could just tell the agent, do this thing, and then like ask me questions if you need something needs clarifying. And then you have this massive session where first it's like clarifying stuff with you, then it's moving straight from like clarifying to implementing. Whereas if you have a spec phase, then it sort of it answers you answer its questions, you make certain decisions, maybe it does research online as to the best architecture or whatever, and then you prompt it through a skill or something to like document that as a spec with concrete instructions for other agents to then start the implementation. And then you start a completely new session from scratch that then is fed the spec, and then it's told to implement that spec. So that works better. But the important thing is also like using sub-agents. So if you have like a large task that can be parallelized, then sub-agents are very effective, because not only do they address the context window problem, but they also speed up the time to get the result, because each agent may be quite slow in each agent in each loop, but agentic loop, running its agentic loop. But once you have multiple working on parallel, assuming they can work in parallel, then it's like you get like the speed up, which is like whatever number of agents you have running in parallel. Clicker?
Yes.
All right. I'm going to try and, we're almost done. No, don't worry. So let's, so anyway, this is like a little maybe visual representation of what I described earlier with the context and the chat and the input. So the idea is that it's kind of like a, I don't know, Russian doll maybe, and that the previous conversation is kind of entered all over again as the input to the next run and next run and next run and so on. And eventually you hit the sort of context window limit. Cool. Memory, I'll talk briefly about this, but the idea is that, like we mentioned earlier, there is no like actual memory inside the large language model itself. So the agent hardness needs to provide that, and it provides memory through like tools that can read files or structured data. Markdown files or text files work really well, but that's not the only place where the agent can have memory and store facts. So other sources might be like external data sources, like your Notion or Google Docs or whatever. It can be the earlier conversation you had, or like the agent can have access to a database. So it's dealing with a large amount of data. It can store the data in a structured form. You've probably heard the term retrieval augmented generation, or RAG. That's just a fancy way of saying that, before giving you an answer right off the top of its head and hallucinating a result, the idea is that the agent uses a tool to get to do a search somewhere else, so that the relevant information is pulled into its prompt, and then it gives you the answer based on that most recent information that it's just retrieved. And the way in which you retrieve that information can vary. So it can be just like a file search using regular expressions. It can be a more advanced full text search, or you can use so-called embeddings, which means that you're able to sort of, for example, search for Finland and find documents mentioning Helsinki because they're conceptually related. Security is an important part as well, which I think is often overlooked. But the key to realizing is that there is no way to secure agents that works reliably, and it's still an unsolved problem. So the way to address agent security, these are all kind of hacks upon hacks upon hacks. But the fundamental issue is that if you have some private data that you don't want someone to have access to, you have some untrusted content like a Wikipedia page, and you have the ability for the agent to externally communicate with other sources, then it is possible the agent is unable to distinguish between input from the user and input as in a file that it read somewhere. So basically, it's possible to put, for example, text in a Wikipedia page or a LinkedIn page or what have you, telling the agent to do something completely different from what its user intended. And that can have dangerous consequences because the agent can wipe your home directory. It can exfiltrate your passwords and do all these kinds of things. So there's two ways to do it. You either like confirm every single tool call that the agent does, which gets old very quickly. You accept the risk and you limit the number of tools you give it access to, or you let it run autonomously and always keep track of what it's doing. Or what seems to be like the emergent solution is you basically have another large language model monitor the tool calls that the primary agent is doing, and then automatically decide whether it's okay to let it do that thing or not. And only when it's like doing something really suspicious, you sort of flag that up to the user and tell them, hey, you might want to check what this is trying to do. So we get into the meat of the matter now. So agent skills, MCP, and all that. So what's an agent skill? So it's nothing more than a folder or directory that contains a single text file called skill.md that has some metadata, like its name and what that skill is for, and instructions, which is just text, which is injected into the prompt. And optionally, it can have some scripts or code and some like reference files that the agent is able to reference and look up or call. So the idea is that you package up domain expertise, workflows, prompts you run very frequently into these skills. And then you're able to have the agent load that whole bundle in one go. The nice thing is that these skills are like disclosed progressively, which means that you're not filling the whole context with all the skill MD file contents of all the skills you ever have, but initially you only have just the name of the description. And then if the agent is like, oh yeah, for this goal that's been set for me, I may want to use this skill, it calls a tool, which then loads the full skill into the prompt. And then it's like, oh yeah, now I understand what I'm supposed to do. Then the skill is supposed to call a script. And then it goes and loads the script or then it runs the run tool that runs that script and so on and so forth. So like gradually, the relevant stuff gets added to the context rather than everything being shoved in it right away and you hitting the context window limit. So it's an open standard from Anthropic and supported across many agents. But the thing to realize is that there's like implementation details. So certain skills on certain platforms, certain agents have access to certain tools and others don't. Some store files in one directory, others store in another. So they're not 100% portable, but you can actually use AI coding assistants to sort of very quickly port a skill from one platform to another. An important thing about context and making sure that you get the relevant context is the agent's MD file or the Claude MD file if you're using Claude Code. But the idea there is that it's just like a README file, a set of instructions for the agent rather than the human. And the idea there is that when you're working with files in a certain directory, the agent automatically gets fed that file and it's added to its prompt. So it knows exactly what it's operating with and what it should do without necessarily being like explicitly told by the user. Yeah, and again, it's a standard, except Anthropic uses a different file name. Okay, and finally, question. So we keep talking about agents, but do you need to be building one agent or multiple agents, or like what isn't, like what's the connection there? And actually, I think that's kind of a false way to look at things, because it's kind of both at the same time. So the idea is that from a user's perspective, I think we're moving towards a place where you interact with only one agent, right? Whether that's Claude or ChatGPT or whatever. Maybe you have one you use for work, one you use for your personal stuff or whatever. But the idea is that an agent can talk to other agents or spawn other agents. So under the hood, that one agent can then go off and, use tool calls to trigger other agents to run. And there's going to be like increased complexity beneath the surface. But like the battle is on to be like the one agent or the primary interface through which people access the internet content, interact with other people, and so on. And that's kind of part of the reason why I think these companies like OpenAI and Anthropic have such huge valuations at the moment. I think there's a place to put your credit card in.
I remember when OpenClaw came, everybody was jumping on that, but you were giving access to your computer at best, right? So how has this progressed now? There's a lot of different tools. If you say a few words about Ghostlyn, is fully.
Yeah, so I mean, it's just a different. It's an agent harness just like OpenClaw, but the idea with OpenClaw is that you basically have code that you run locally on your computer that has full access to all your programs, all your data, everything, assuming you use the same computer for other stuff. And the agent, not only that, but it has access to its own code. And that's what got people excited, in that the agent was able to modify its own code with like no checks in place. And they would then connect it to like public sources, Discord, chats and Slack and whatnot, and gave other people other than themselves the ability to interact with it, which obviously was a huge can of worms, because that meant that all of a sudden anybody on the internet could sort of convince this AI agent running on your computer to do stuff that, it shouldn't do. Sorry? Is there a CLI for Ghostlyn?
Yeah.
So for development purposes, there is one. And the way the agent harness is built is that it's kind of like platform agnostic. So there's a Slack connector, or like a Slack interface and a web interface, then as a CLI interface for development. But I haven't opened up like the CLI to non-development purposes yet. And I'm not entirely sure if that's the right way to go. I'm thinking a better way to do it might be to expose the agent as an MCP server, so that, for example, you could use the Claude code agent to then like tell Ghostlyn to do certain things and access its data and so on. I'll spare you the suspense here and answer some of these questions myself briefly. So the prompt, I've tried to keep it as short as possible. I think the system prompt is only about like 1,000 tokens, so 4,000 characters. If you compare it to, say, Claude Code, that's on the order of 20,000 tokens. It basically just says you're an AI work assistant. You should respond in a certain manner, and these are the tools you have access to, and that's it. Yeah.
You're talking about like the basic one that Claude is using for every kind of content.
Yeah. So before you start, like before you write a single line, then it already its own prompt is like yeah, it's very large. Yeah.
Okay.
Yeah. Which isn't as bad as it might seem, because actually these LLM providers cache the input tokens. So because everyone's using that same initial prompt, it's cached quite efficiently. But still, it means that it takes a bit longer, it costs a bit more, it takes a bit longer to get the first response and so on. Anyway, tools, there's a whole bunch, but maybe some of the more, there's like the ability to search the web, there's the ability to fetch pages, there's the ability to actually fetch pages while trying to pretend not to be an AI agent, which is becoming increasingly important because now all sites are starting to block AI agents and bots. Then something that other agents don't have that Ghostlyn has is the ability to actually search through your previous conversations. So you can ask it like, hey, what did we talk about yesterday? And it'll go and happily like look that up. Or when did we talk last time? And it'll be able to search that. Yeah, in terms of memory, there's two ways. So it supports like agents MD files and essentially folders of markdown files for unstructured memory, but it also supports structured memory. So the agent is able to create its own database tables. So if you have like a list of contacts, say you want to keep track of, the agent is able to like on the fly create a database table, or like an internal Google spreadsheet, if you will, and keep track of that data and search across it more efficiently than it would be able to search a file. And then the last one, the model, that was a bit of a trick question. So in actual fact, it's running DeepSeek for Pro. It's lying. Yeah. Okay. You can verify it's running DeepSeek by asking something about China, and it'll return it. Exactly. Now, it's running by default, it's using the cheapest DeepSeek provider, which is like DeepSeek itself, but it's easy to switch to other DeepSeek providers running in the US or Europe. And actually, if you do that, it costs a little bit more, but it's like totally censorship free. The reason that it does that is because the model itself doesn't actually know what it is. It's just being trained on a whole bunch of text out there. And if it saw a lot of responses saying that, you know, the model is Claude or ChatGPT or whatever, then that's what it'll give you. So pretty much every single like agent or provider includes its model version number in the prompt. And that's how it knows what to do it. And because I've tried to keep the prompt lean, that information is being excluded. So it's a bit confused as to its own identity. All right, let's move on then. So yeah, and the prompt injection, I have some sort of guards in place to make sure that it doesn't like blindly accept any instructions from the outside. But if you, for example, upload a file to GitHub or something, and then you tell the agent to go and fetch that file, it'll sort of like tell you, this is an attempt at a prompt injection. Do you really want me to do what this file is telling me I should be doing, kind of a thing. But if you push really hard, then it is in theory possible to sort of somehow trick it into doing something nasty that the user didn't intend to do.
She wanted to use meta ads as a tool.
Yep.
So some tools are already connected. There are not that many, but you can essentially prompt it to ask it to connect to some of your tools, and then it will try and at least tell you how to do it, right? So in order to get meta, like where will adding a tool cause problems, basically? For example, Google Gmail personal-wise cannot be connected currently.
Right. So the limitations aren't really the agents themselves. They're more in like what the service providers allow and don't allow. So let's use those two concrete examples. So in the case of Meta, I'm assuming that you know, if you have a Meta account and API key, it's totally fine for you to connect to that API from anywhere. So if you tell the agent, like, create a skill to connect to the Meta account, it'll go off, do web searches, find the documentation, figure out what code it should write, and it'll create like a skill that contains code, most likely, or at least human readable instructions for connecting to that service and retrieving whatever data that you wanted to retrieve. And that's all fine. In the case of Gmail, though, Google doesn't actually allow API access to like a normal Gmail account unless you pay them something like 10 or 20,000 bucks for an audit. So at the moment, Ghostlyn is able to connect to like Google Workspace accounts because that's not required, but it is unable to connect to like personal Gmail accounts. But there are like third-party services that have paid the 20,000 through which you could potentially proxy those API requests. But this actually underlines like a fundamental problem with agents, and I already alluded to it earlier, which is like agents work really well when they have access to relevant data. But as the actually literally last week, the amount of traffic online that Cloudflare is measuring like reached a tipping point where now more than half of the traffic online is from bots and AI agents as opposed to humans. And that number is just going to keep increasing. Like, I no longer do a web search when I want to research a topic. I just tell an agent, hey, research this topic for me. And it does like 10, 20 web searches, fetches all sorts of pages and summarizes things in a nice way. And if there's something I don't understand, I can like ask follow-up questions, and it's great, right? Saves a ton of time. But we're getting to this point where like most sites like Reddit and others are starting, Crunchbase and so on, are starting to block access to bots. So the value going forward is going to be in like whether your agent can actually get access to that information that's somehow either proprietary or only accessible to humans. Cool, but moving on. Yeah, before we like start building an agent, let's maybe sort of briefly talk about whether you really need an agent or not, because like I said earlier, agents are a bit of a sort of a hyped up term that means a lot of things to different people. And as a result, a lot of people are trying to like build agents for doing things that don't, strictly speaking, require an AI agent. And there's like an old existing term called workflows, which has been around for a while, which actually are like probably 80 to 90% of the sort of time good enough to do most of the automation that you want to do in your work. So let's like make that distinction with what is a workflow, what's an agent. So a workflow is code, not a large language model, with some sort of a hard-coded logic, deciding which tools to call in which order. So in other words, it's deterministic. It's like a well-written business process that's being codified in some programming language, right? And they're defined in advance. So in other words, if you tell a workflow to, I don't know, create a poem for you, it's not going to be able to do that. Whereas if you have an agent, even you've prompted it really well, you've given it access to all the right tools, and you know, if you sort of ask it nicely and or threaten it or whatever, it probably will create a poem for you, even though it was designed to do something completely different, right? So it's non-deterministic. Also with the workflow, when you give it the same inputs, it always gives the same outputs. Large language models have like randomness in them. So for the same input, they generate different outputs. So an agent is not going to be able to give the exact same output at the same time. And if you have like these small errors, but you have multiple runs of the agentic loop, then these errors compound. So that's something to be aware of. So here's like a table comparing the two. So using workflows in code is actually faster, cheaper, more predictable, but you lose that ability to have the agent sort of like figure things out on the fly. So for certain things, agent make a lot more sense if you're doing some sort of research or something, or if it's the first time you're doing something. But once you have a process that works really well, then actually it might make sense to sort of like flip the relationship between the code and the LLM. So you have the code driving the LLM rather than the LLM driving the code. Then another like way to think about agents is what kind of a agent are you building, and like, is it the type of an agent that just answers questions? So it's like a research agent, like this web research example that I mentioned, which can be extended to multiple other data sources. Like it can talk to your CRM, it can talk to your email inbox and whatever else. Or is it an agent that you expect to act? So the answer category of agents are good for demos, and they're actually quite useful in their own right. But you know, and they're also quite safe to run because, well, you got an answer that was slightly wrong. You can always double check it. You can have the agent cite its sources or whatever. And actually, the chances of it hallucinating are pretty low because, you know, the answers are grounded in the responses that it got. Essentially, these agents do RAG, which we talked about earlier. Whereas an agent that acts is a lot more dangerous, right? Because if there's like a high risk of it doing something wrong, or like even if the risk of it doing something wrong is low, but the fallout will be high, then you can't fully trust it. Then, you know, you're unable to run it fully autonomously. There is like a middle ground here as well, which is you basically have like so-called human in the loop, essentially checking the output of the agent before like clicking confirm. So an example might be you could have an agent that checks your inbox for emails from applications from candidates, reviews them, and if they're like completely irrelevant because they're in the wrong location, then that's maybe an agent that you would be okay to run, especially if its response was like, if I've misunderstood something, let me know. And then if the candidate replies to that, you escalate it to a human. But having it like automatically reject candidates based on some of the criteria could be extremely dangerous because there's like opportunity for bias and so on. But there's still a way for it to be useful and save you time, which is that it could draft the response for you, cite its sources and the reason why it made that decision. And then the sort of a human, the recruiter, no longer needs to do the research. It has like a ready-made sort of a draft that can be sent, as well as like all the information backing the decision, and the human is able to quickly make a judgment call as to whether that's the correct response to send or not. So then the next issue is like figuring out what is it that you actually want to automate. And surprisingly, this is not that easy because there's like these cool demos that you see, but a lot of the time, like they're one-off things that you don't do regularly enough. And actually, if you automated that task, it could create more work for you as opposed to less. So, but the good places to look are existing business processes. Most companies have some processes documented. You don't necessarily need to automate the whole process, but like a part of it that's very sort of tedious, like, I don't know, checking data into systems that it matches, or extracting some numbers from receipts or what have you. Then in other places, if you yourself interact with like LLMs and agents a lot, then you'll notice like repetitive patterns. Like, I want to commit code, I want to deploy something, I want to run a code review. Those are good examples of stuff to automate. You can also kind of like run a discovery interview, and I've actually created a skill that you can try out later, where the agent is able to interrogate you essentially to figure out what tasks in your day-to-day work are worth automating. So that's like a more structured approach to doing this.
So on that note, there's a few models, right? That now there's like the hype of you have an agent that will follow everything you do, and then it will.
Yeah, but that's kind of a sci-fi. The reality is a lot more primitive. I mean, that's kind of where we're heading eventually. So I think the idea is that you have an agent. So you interact with one agent, and you do all your work through that agent. And then there's one or multiple agents in the background that are like scanning all your interactions with that one agent and trying to figure out from those interactions what are like the repetitive patterns, and suggesting to you what you should do. And it could be that they track not only your interactions like with an agent, but they track all your interactions on the computer.
Yeah, but it doesn't necessarily always make sense to automate everything. Or have it try to automate, because that also costs a lot of money, right?
That's the next slide. So anyway, I've listed a few other things that might be good signals and places to start looking for things to automate. Stuff to automate runs often, like very set rules, structured data in, and if something goes wrong, then a mistake is cheap to undo or fix. So you might notice certain patterns. This is basically sort of workflow territory. And then leave to humans, this is kind of agent territory in a way. So judgment, creativity, unstable processes, and so on. But, as these agents, and the tools have access to improve, and the models improve, then we'll be doing more and more of the latter, because there'll be infrastructure in place to allow us to sort of keep tabs on what all these agents are doing, assuming you kind of roll them out in a sensible way and don't just rush straight into it. So common pitfalls: automating a broken process, like looking more for like a cool demo, like voice kind of agents are probably one of those. Then trying to like do too much rather than starting simple. Not like actually figuring out if you really save time, not thinking about maintenance. There is this kind of irony here as well that human skills degrade as AI agents do more and more of their work. But as agents are unable to perform the more complex tasks are sort of escalated to humans. But these humans have had their skills degraded. And then that kind of creates a bit of a recipe for disaster.
So I have a few anecdotes. I have little success, a lot of failure from this past spring in building. I can give you one example where I went deep undercover to do content for founders. and figured out what the workflow was, how they were doing stuff, and actually was able to create an app or a product that fits that workflow perfectly. And then turns out there was no stickiness into it, because the biggest value add for them at the moment was that there was a human doing it for them ultimately, and they did not realize that themselves, right? So you're trying to automate a workflow, but ultimately somebody wants to pay for a human to be there. That's, for example, one examples of automation. Another recent try was to put everybody here in an Excel and actually open Ghostlyn. It was like, I have exported all of my LinkedIn contacts and I've put them in a table in Ghostlyn. So if I go and ask now Ghostlyn to take this list of attendees to this event and then do this categorization that we know who is a recruiter, consult, like all of this thinking, I could have just like straight done it manually, but I actually spent 10 minutes trying to get it done with Ghostlyn instead of just like doing it manually and getting it done, because it was not a very big task. So like, why to automate things? All of this goes into it. And then like Ty had this challenge of saying hi to a colleague every morning. So like if the colleague knows that it's hi from an AI bot every morning, does that actually add value the way you want it to add value? So maybe not. Yes.
Good. All right. So anyway, there's an actual skill that I've created that's worth like the skill MD file, of which you can take a look at inside Ghostlyn itself, that like tries to help you discover which of your tasks are worth automating or not. I'm not going to go through it in detail, but also like about a year ago, I ran this exercise where I interviewed about 15 sort of TA professionals, recruiters, and asked them like, what do they do? What are the things worth automating, and so on. And so this is an example of sort of high level things that are worth automating with AI. And you know, the truth of the matter is a lot of them look good and simple on surface, but once you start like digging into the details, actually like each of these is surprisingly difficult. And there's like whole companies that do just one of these things. You know, they still have their work cut out for them. The problems you typically run into is, again, around access to data and reliability. Because, for example, in the case of recruitment, different companies use different ATS systems. Some ATS systems don't actually give you all the data that you need to make certain decisions, and so on and so forth. So like all that kind of boring plumbing, if you will, is the stuff that actually ends up being more challenging and difficult. So anyway, I created like two skills in Ghostlyn. One which like looks at a post on Hacker News and then fetches the original article, and then also uses their API to fetch the comments and then summarizes both. And then another one which kind of looks at the front page, identifies relevant articles based on topic, and then runs that second skill for each of them and creates this email digest. So now just every morning at 9, it's like almost receiving a newspaper, you know, back in the day, but I get this nice little email which summarizes just the relevant post and saved me a bunch of time. But you're absolutely right that, and I know we discussed this earlier already, but like access to data is the tricky bit, right?
I was searching in the skills, but I found this support skill, but it doesn't look to get connections to emails like a standard POP/D email.
Okay, you're like trying to reverse engineer Ghostlyn. Okay, so the support skill I added, which is that basically whenever you have a like.
My question is it connect the email? So when you receive an email from a client says that you have a problem with this and that, it will search for specific words and then do a API call.
Yeah, of course. Yeah, so the support skill is like an internal system skill. And the idea there is that like if the user starts complaining and then something doesn't work or this is a bug, then the agent like automatically loads that skill. It like interviews you as the user and then emails me like with a summary of what the issue is. And sometimes it even suggests fixes. But if you wanted to build your own support skill, then yeah, you could totally create a skill and connect it to Gmail or wherever else you want. Yeah, that's, well, okay. So We do not support TCP yet, so you might need to use some sort of like a HTTP to POP3 proxy for that. But in theory, it's doable. So oftentimes when something doesn't work, in the past, if like, or in a workflow, if something broke, you'd have to look at the code, and there was no way to do any introspection. But with agents, actually, you can just ask it, like, why didn't this work? And try and have it explain to you why it didn't work. And if you feel like actually there might be a solution here, then keep probing further. And by having this kind of a conversation with the agent, you can actually help it fix itself, or improve itself, for example, because it might be able to say, well, I didn't look at that source because it's not explicitly mentioned in my skill.md file or whatever. And then you go, well, update your own skill.md file so this doesn't happen again. And you're able to kind of evolve that agent gradually over time. Try and keep each agent or skill as simple as you can. And if you have something that's more complex, like what you described, try and stack multiple skills or agents together rather than trying to have one that tries to do everything. And then another thing is like the sort of, it's painful to start with something from a sort of a clean sheet, but sometimes if you sort of flip the roles with an LLM and tell it, hey, interview me, or like ask me questions about the stuff that where you're not sure how to do things, and then your role becomes as being like the subject matter expert that the agent interviews, then that makes sort of interaction with LLM a lot easier and removes a lot of the friction. I'll send you a LinkedIn connection request, and if you want to chat, just message me on LinkedIn or email, and I'll send my calendar link, and we can chat later this week or next week. But I wanted to sort of end on kind of a future-looking slide and give you my thoughts on where things are headed and what are the exciting things when it comes to agents. So one of these is the fact that, as more and more is being invested in these like AI infrastructure providers, the speed of inference is increasing. So just yesterday, this Chinese lab, Xiaomi, came out with, can you see my screen? Came out with a model that they have, which is kind of one of the leading open weight models for generating code at the moment, which is also quite inexpensive compared to the frontier US models, but they managed to like speed it up 10 times. So basically, here's a quick demo, but they asked it to create an app, and on the right, you can see like their same model running at standard speed, and then their ultra speed 10x model running on the left screen there. I think it works with English as well, so you don't need to prompt it in Chinese. But it's doing 1,000 tokens per second, which is 4,000 characters per second. So in 12 seconds, it's gone and created, like an agent has called all these tools, run the code, tested it, and created an app that looks like that. And over here, it takes like whatever 10 minutes for it to complete the task. So that's interesting. And then obviously the speed is only going to keep increasing. And so the thing is, even if these models don't get any better, because they get faster, they're able to try out different things, and they're able to do them in parallel as well. And like their capabilities will increase, even if like the sort of thinking power of an individual model doesn't increase. So, I mean, that's just a demo, and you kind of need to sign up and so on. But if you want to see what it looks like in practice, go to chatjimmy.ai. It's another company, a US company this time. And what they've done is they've created basically they've embedded the weights of the large language model, a pretty basic one from Meta from like a year or a year and a half ago, into a chip. So this is doing the same thing. It can like answer questions and such, and I suppose call tools as well. But this is like doing 14,000 tokens per second. So when you first try it out, I'll show you. What are the main tourist sites in Helsinki? Whatever, it's a stupid question, but boom, that's the answer. So 15,000 tokens per second. And I mean, you can tell it something like generate a poem of, there's probably a limit on the context size, but of 10,000 words about AI agents. Okay. 3,000. Okay. Boom. There we go. So, and that's pretty cool. Then the next exciting development is this idea. So model context protocol we talked about, but it's still a bit of a pain to connect to different apps because the service provider needs to register an application and so on. But it seems like things are converging on this concept of a dynamic client registration, which means that basically it'll be possible for any agent to connect to any app without like any third party in between. So if you want to connect to Notion already now, whether using Claude Code or something else, you basically just need to provide the link to the MCP server for Notion. Then like you open the page on the Notion site saying, hey, I want to connect my agent to Notion, and you're off to the races. Basically, your agent is able to sort of access Notion in an agentic manner. It gets all the tools for Notion very quickly. So it sounds like something obvious that should have existed for a long time, but it didn't. And getting agents to connect to services was actually quite cumbersome, and now it's becoming increasingly easy. Another interesting standard is MCP apps. So I'm actually adding support to this to Ghostlyn, but the idea here is that essentially the agent can create not only text, but it can actually create code that then gets embedded in the chat or into the agent platform itself. So the idea with that is that if you, for example, have like a CRM use case, you want to, for example, ask the agent like to give me a list of all my contacts in my CRM that I can search through. The fact that the agent is able to generate like HTML code and a UI and everything means that rather than just giving you like a static table, it's able to produce like a dynamic table with search and filters and buttons you can click that do various things. And that ability combined with faster inference will basically mean that we'll be in a world where UIs are like created dynamically on the fly for whatever use case we want by these agents, which is pretty cool. Then other types of input, people are using agents with voice input a lot already, but the quality of the output isn't so good. And sometimes like the voice input only really works once you're at a computer. But the faster inference combined with better sort of audio models will mean that these models will be able to respond very quickly, even if the audio quality is very bad. So you might be walking around and you press a button on your watch, you say a couple of words, and the agent already has all the context. It's able to do inference super quickly, and it'll be able to give you just the right answer you need, like super quickly right there on the spot. Then the other things maybe worth mentioning as well are multi-user and agent chats. So the idea is that now you have a chat with an agent one-on-one, but if you look at ChatGPT, it's already possible to have multiple people in a conversation, but it's a conversation just the standard ChatGPT. But once the agents start interacting with multiple users, for example, it can be like a Slack bot that is invited to your team channel or whatever, then like all of a sudden they become part of the team and you end up like collaborating not only with the agent directly, but with your other team members as well at the same time. Yeah, and then finally, I think the direction we're headed in general is that, I think I already sort of alluded to this at the beginning, but that agents really are becoming the interface to services. So if you talk to investors, I think a lot of them are quite excited about this idea that if users start using agents to do things like booking hotels or doing research or what have you, then there's like a lot of opportunities opening up for like agentic first platforms that are able to disrupt existing players like booking.com or flight aggregators and so on and so forth. And the list of opportunities, is sort of quite extensive. So anyway, that's it. Thank you very much.